All right. So continuing on with our little process, I'm going to go ahead and now explain a little bit more further transformations. So I'm going to go back to my also faithful parent function 2 to the x. So again, f of x equals 2 to the x. I'm just going to go ahead and graph it. Here we go. Okay, so again, I'm just going to go ahead and create my graph. And we'll go from there. Okay, so again, remember, if you need to see an overview on how I created this one, look at my previous video that says exponentials, but we're going to go ahead and graph this guy. Again, 2 to the 0 is 1 right there. 2 to the 1 is 2. 2 to the 2 is 4. 2 to the third is 8. So right there. 2 to the negative 1 is 1/2. Negative 2 is 1/4. So this function right there, this is 2 to the x right there. Okay. So now the first function we're going to look at now is, there we go, g of x equals negative 2 to the x. Okay, what did we just do? All I did is I took the entire function and now I added a negative to it. So let's see. 2 to the 0 is 1, but now I added a negative, so that's going to be negative 1. 2 to the 1 is 2, but I added a negative, so that's going to be negative 2. 2 to the 2 is 4, but I added a negative, so that's going to be negative 4. 2 to the negative 1 is 1/2, but I added a negative, so that's going to be negative 1/2. 2 to the negative 2 is 1/4, but I added a negative, so that's negative 1/4. Okay, let's see what we have. 0, negative 1, 1, negative 2, 2, negative 4. I'll probably have 3, negative 8. Okay, negative 1, negative 1/2, negative 2, negative 1/4. So I now have something like this. What do you notice? I have some type of reflection. Where am I reflecting against? I'm reflecting against the x-axis. So right here, this right here is a reflection against the x-axis, and the x-axis is y equals 0. Okay? So this means whenever my outputs were positive, they now become negative. Okay? And that's because I added this operator here that's affecting the outputs of this function. So moving on to the next one, I'm going to leave that one there. And now I'm going to do another type of reflection. So let's see. Let's call this h of x is equal to 2 to the negative x. Where is that negative now? The previous one had the negative outside the base, so it was the entire function times negative 1. Now I'm just multiplying or amplifying that power by a factor of negative 1, so it's up here. So let's see what we get. So h of 0, 0 is neither negative nor positive, so that guy is still going to be 1, okay? H of 1 means 2 to the negative 1, which means 1/2. H of 2 is 2 to the negative 2 this time, so that means 1/4. H of negative 1, so 2 to the negative 1 becomes positive 1. 2 to the 1 is 2. And let's see, 2 to the negative 2. So I'm going to do this one right here so you can see. I have 2 to the negative x. Okay, so I have h of negative 2, which means, I'm going to erase that a little bit. 2 to the negative -2. Notice I have that right there. A negative times a negative becomes a positive, and that's going to give me 4. See that? So now I have my points. So now I'm going to go ahead and go, let's see, -2, 4, bloop. -1, 2, right there. 0, 1. 1, 1/2. 2, 1/4. And if you notice, here is my graph. So now, if we look at this, where is my reflection? My reflection is now against the y-axis. So when I have an exponent now that switched from positive to negative, this is now a reflection against the y-axis. And the y-axis is x equals 0. So let's go ahead. We've done horizontal translation, vertical translation, and now we have reflection against the x and y-axis. So now we have additional tools that we can look to see where our graphs are going. So we're going to go ahead and look at a couple of equations and now know what's happening to my equation. Okay? So let's see. State the transformation. Let's state the transformation. So number 1, I'm going to have, let's call this f of x equals 2 to the negative x plus 3. Let me write this a little nicer. Oh, yeah. So looking at this like this, what do I have? Let's see. It's in the power, so now it's here. So that means I have reflection against y-axis, and I have a vertical translation 3 units up. Okay, so let's see what that means. I'm just going to go ahead and graph it. Quick little sketch. And I'm going to also graph the parent function. So remember, my parent function is right here. So I'm just going to do 8, 4, 8, -4, -4, -8. Cool. So I'm going to go ahead and graph my parent function. Again, 2 to the 0 is 1. Parent function is 2 to the x. That's the one that we always compare against. 1 corresponds to 2, 2 corresponds to 4, 3 corresponds to 8, -1 corresponds to half, 1/4. Here is my parent function. This is 2 to the x. That's my parent function. So now we're going to look to see it's a reflection. So again, I have a reflection that goes like this, right? But now it's going to be moved up 3 units. So it's going to be 1, 2, 3. That's my new anchor point. And it's going to reflect. So right there. Why? Because there was technically 2 things that happened. I reflected it. So here's the reflection. This is just the reflection. And then I moved it up 3 units. So if you can see, my red is my f of x. Right there. Cool? Let's do another example. Let's do g of x is equal to -2 to the x plus 3 minus, or just like that, -2 to the x plus 3. So let's see what's happening here. I have, that means I have a reflection where my inputs are going from top bottom on x-axis. And I also have a horizontal translation. It's happening in my inputs, and it has to be opposite of what the equation tells me. So I have a horizontal translation 3 units left because it says plus 3. Okay, let's go ahead and see what that graph looks like. Again, my parent function, my basic function is just 2 to the x. That's the one I'm going to compare against. So here I go. Okay, so again, 0 corresponds to 1, 1 corresponds to 2, 2 to 4, 3 to 8. This is just the parent function right here. That's my parent function, 2 to the x. And I recognize that this function is going to be shifted 3 to the left. So 1, 2, 3 that way. And then it's going to be reflected. So again, my anchor point is going to move 1, 2, 3, 3 to the left, and then it's going to reflect. So now here, it's my new function right here like this. Why? Because, again, this is my function. Because I took this function, it got reflected, bloop, and then it got moved 3 units. Oops, sorry. It got reflected here like this, bloop, and then it got moved 3 units to the left. And this is my resulting one. So I hope you can understand my transformations now. So now you have 3 different tools. You can see where if the function has reflection on it, if it goes from positive to negative, also an horizontal and vertical translation. Okay? Okay, stick around. These are all review videos. I will be posting tonight some more videos for us to all review and make sure we have these subjects fully grasped. See you soon.